Hi, this instructional video is about absolute value inequality, solving absolute value inequality. Here's number one. To solve, you have to isolate the absolute value. Make the absolute value of x plus 1 by itself. To do that, we're going to minus 2 to both sides of the inequality. So this is an additive inverse, so 2 minus 2, they cancel out. So all you have remaining is now absolute value of x plus 1 is greater than 4 minus 2, which is 2. Now that the absolute value is by itself, you could solve for whatever's inside the absolute value. What will be inside that will be greater than 2? Well, 3, 4, 5, 6, 7, all those numbers are greater than 2. Or even if you put a negative number in there, since the absolute value of a negative number is also positive, it could also be negative 3, negative 4, negative 5, 6, 7, 8, so on and so forth. So, this can be either positive or negative, so we're going to take whatever the expression inside, x plus 1, and we say that x plus 1 better be greater than 2, or whatever that x plus 1 is, should also be less than 2. What's less than 2? Well, 1. I'll show you what I mean in a minute, okay? So, here's how this, negative 2, I mean. Because what's less than negative 2? Negative 3. And absolute value of negative 3 is still 3 greater than 2. Let me just get to solving this thing, okay? So here we go. So we go minus 1 to both sides of the inequality for this guy. So 1's cancel. X is greater than 2 minus 1 is 1. So whatever you put in there, it better be bigger than 1, like 2 or 3. Or solve this one as well, then you get x, this cancels out, is less than negative 3. However, you cannot leave your answer like that numerically. You have to have a number line. Yeah, remember? And also, when it's not equal to, this is greater than, but not equal to. The 1 is a bigger number, goes to the right side of the equation, number line. And this is negative 3, the smaller number goes on the left side. Not equal to means open circle. If it was equal to, that would be closed circle. And greater than 1 means all the numbers that is on the right side of the 1. So 2, 3, 4, 5, 6, infinity. And less than, not equal to, negative 3. What's less than negative 3? Negative 4, negative 5, negative 6 to negative infinity. So how do you write this to match the number line? You say x is less than negative 3 or x is greater than positive 1, and that becomes a numeric answer. And this becomes your graphic answer with a number line. Now you try numbers 2 and 3. Okay, you said isolate the absolute value. To do that, you add 3 to both sides of the inequality. So negative 3, positive 3 cancels out. All you have remaining on the left side of the inequality is absolute value of 2x minus 8. On the right side is less than or equal to 5 plus 3 is 8. Now that the absolute value has been isolated, there's 2 possible values you must find for that inside the absolute value. Whatever you get for 2x minus 8, it better be less than or equal to 8. Or, whatever you get for 2x minus 8, it better be greater than or equal to negative 8. What's greater than negative 8? No, not negative 9. Negative 7. Negative 6. Closer and closer to 0, not the other way. Let's just solve it. So you add 8 to both sides of the equation on this one, inequality I mean. You get 2x is less than or equal to 16 divided 2. So the numbers you choose better be less than or equal to 8. So that's one of the numbers on the number line. This one, you add 8 to both sides of the equation, just like before. So you get 2x is greater than or equal to 0. You still have to solve for x by dividing the coefficient 2. So when you have a 0 on top of any fraction, it stays as a 0. Now, how do you write this how do you show this on a graph, number line? Well, the bigger number is 8, so that goes on the right side. The small number is a 0, let's put that on the left side. X is less than or equal to. Since it's equal to, we're going to fill it into the circle to say 8 is part of the answer. And this is less than. So all the numbers less than is like 7, 6, 5, 4, 3, 2, 1, 0, and go so on and so forth. But also, the number you choose better be greater than or equal to, so it's a filled in circle, to 0 and to the right. So what do you have to choose for numbers that will make this inequality true? The numbers you choose better be between 0, not between 0 and 8. Between, not between, I did it again. 0 and greater and 8 and less. Anywhere there. Oh, there, let's leave it at that. There's your graphic answer. How do you write that numerically? You say X is less than or equal to 8 and greater than or equal to 0. And that's how you write your numeric answer. Now this one was kind of horrendous, wasn't it? Alright, now let's do this a little differently than the way I showed you the absolute value equation. Let's go ahead and combine these like terms. There's a 2, there's a 3, they're both positive. So let's write that as 5 minus absolute value of 5x minus 4 is equal to negative 19. Let's go ahead and move the 5 to isolate the absolute value. So minus 5 to both sides of the equation. This becomes a bigger negative then. So we have negative absolute value of 5x minus 4 is equal to negative 24. Now I still have to get rid of the negative coefficient. There's an invisible factor 1 negative. To do that, you could either multiply or divide a negative 1 to both sides of the equation. Oh darn, I forgot. I made that into equation. Let's go and make that into less than. I hope you were using pencils. So this becomes less than. Because now I also have to show you, anytime you multiply or divide a negative number, anytime you multiply or divide a negative number to both sides of the inequality, you have to change the direction of the inequality. You probably saw that somewhere before too. Okay? Anytime you multiply or divide a negative, you have to change the direction of the inequality. Now as a result here, the negative simplifies out to become a positive. Now absolute value has been isolated. And now this is going to be greater than negative 24 over negative 1. They're both negative, so they become a positive 24. Now we can solve this inequality two different ways to say 5x minus 4 is greater than 24. Or 5x minus 4 is the opposite direction, less than 24. Okay? When we have an absolute value inequality, you always have to change the direction and the sign. I almost forgot that too. Okay? Alright. So here we go. To solve this, we go plus 4, plus 4. Plus 4, plus 4. We're moving simultaneously. This is becoming an assembly line now. Here you go, 28. This is negative 20. Negative 24 plus 4 is negative 20. Divide both sides of the inequality by 5. So x is greater than whatever this fraction is. Ugh. And this is x is less than negative 4. So the number line, which one's a bigger number? 28 over 5 or negative 4? The fraction, yes. Don't worry what that is. Just put that there, 28 over 5. Not equal to, so it's open circle. X is greater than. Greater than means to the right, you shade. Now this one's negative 4 on the left side. There's no equal sign, so it's open circle. X is less than. Less than means to the left. Okay, sounds like some sort of a song. To the left. Now how do you write the numeric answer for this guy? You match it up with the number line. X is less than negative 4. Or x is greater than 28 over 5. That becomes your numeric answer. I'm out of here. Good luck.